Hey guys, I'm Daniel. I'm going to be showing you how to find a KSP when given a certain molar solubility. Okay, so we're given molar solubility, and it's going to be very easy to calculate KSP because the molar solubility is the portion of a certain compound that's going to fully dissolve. Okay, because if you recall, magnesium carbonate doesn't want to completely dissolve. Okay, it wants to stay intact, so only this portion of it is going to be dissolving. Okay. So the first thing to do here is to write out your ice table, or actually the reaction. Let's start off with the reaction. Okay, so we have magnesium carbonate. Magnesium is 2 plus, carbonate is CO3 2 minus, so we're it's just 1 to 1. Okay, magnesium carbonate dissolves into magnesium 2 plus CO3 2 minus. All right. So our equation is balanced. We have one magnesium on each side and one carbonate on each side. So now let's get to making our ice table. So we start off with initial, change, equilibrium. Alright, and it gives us molar solubility, so that's going to be our initial concentration of magnesium carbonate. Alright, so actually let me use a different color. And we have 1.8 times 10 to negative 4 molars. And we start off with 0 molars of magnesium and 0 molars of carbonate because it doesn't say that there's already an existing amount inside the vessel. Alright. And in this case, this portion of the larger sample of our magnesium carbonate is going to be fully dissolving. Okay, so don't get confused and think that anytime you're given a certain volume or mass or any sort of thing that you might be given, don't automatically assume that it's going to completely dissolve, okay? Because it only completely dissolves when you're given molar solubility, okay? So it's going to be changing by negative 1.8 times 10 to negative 4 molars, and the products are going to be changing by plus 1, or actually you don't have to write the plus 1, or actually yes, let me write it. 1 times 1.8 times 10 to negative 4 molars. And that's a plus, and over here plus 1 times 1.8 times 10 to negative 4 molars. Now I wrote that 1 in front of the molar solubility just to highlight that since we have a 1-to-1 ratio, 1 mole of magnesium is going to be made per mole of magnesium carbonate that's put into our reaction or solution, and the same thing goes for carbonate. 1 mole of carbonate is going to be released every time a mole of magnesium carbonate dissolves. All right. So we're given, now we have our change in our ice table. Now let's write out our equilibrium. Okay, so at equilibrium we're going to have 0 molars left of magnesium carbonate, and we're going to have 1.8 times 10 to negative 4 molars times, and 1.8 times 10 to negative 4 molars of carbonate. Alright, and the equation that we're going to be using for calculating the KSP is going to KSP is equal to the solubility of products. All right, so I guess we'll call this A and we'll call this B. All right, and we'll call the coefficient here as X and Y. Okay, those are coefficients and those are products. All right, so we have A raised to the X power and B raised to the Y power. Okay, that's our formula for calculating KSP. And in this instance, we have our concentrations, but in this case we don't have a coefficient that matters. Okay, it's only 1, so anything to the 1 power is just itself. All right, so this is going to turn into 1.8 times 10 to negative 4 molars times 1.8 times 10 to negative 4 molars. Alright, and that's going to equal, let me do the calculation, 3.2 times 10 to the negative 8 power. And that's going to be our molar solubility, and that's going to be our answer. And if you're using the same test, test bank that I'm using, it's going to be letter answer D. And this is number 86. So I hope you understood everything, and thanks for watching, and I hope you understand. Thanks.